find the magnitude and direction of magnetic field at P. So this is the conductor, current is flowing like this and like this. It means this entire thing forms a square, and we have to find out at this point what is the magnitude at this point. Okay, now let us take this segment, that is segment AC. See this, if you are drawing this figure here, see here, this is B, this is C, this is A, this is point P, this one. So since it is a square, this will be 90 degree and this will be 45 degree and this will be 45 degree and this will be 90 degree, this will be 45 degree and this will be 45 degree. Now let us consider this point AC. This is A, C, this is point P. Point P. What is this distance? This side is D, this side is D square plus D square under root. This side is root 2 D. That is AC is equal to root 2 into D, which is also is equal to BP. PB, because this distance also. Now we want this perpendicular. First we have to draw the perpendicular distance to the point P, because here we are interested to find out magnetic field at this point due to this wire. Hence the current is flowing like this. So this perpendicular, what is this? This half of this distance is equal to this one. Therefore, that is, we call it as L. PL is equal to half of PB is equal to root 2 D divided by 2 is equal to D divided by root 2. This is PL, which PL, which also which can be also told as root 2 by 2D. Okay. Now this distance is equal to D by root 2, this distance. First, see, to find out the magnetic field at any point, suppose at P we want to find out, we take the perpendicular distance, then one end, that is phi 2, and joining this reference line with this one, this will be phi 1, either this is phi 2 or this is phi 1. Now this is the point. Since this is 45 degree and this is also equal to 45 degree, so we got this point P, and this is one end of the conductor and this is another end of the conductor, one end of the conductor, another end of the conductor, and this is perpendicular distance with the conductor here. This is the perpendicular distance with the conductor. Therefore A is equal to, this is A is equal to perpendicular distance is equal to D divided by root 2. Why? Because this can be written as root 2 into D divided by root 2 into root 2. This cancel, D by root 2. Yes, this is A, D by root 2. Phi 1 is equal to 45 and phi 2 is equal to 45. So we can easily calculate what is the value of magnetic field at P due to this wire segment AC. This is equal to, we can write magnetic field is equal to mu naught by 4 pi into current flowing divided by E into sine of phi 1 plus sine of phi 2, where phi 1 is equal to phi 2 is equal to 45 degree, because this is the angle with respect, this is the reference line with respect to line joining one end, line joining another end, and the angle is measured with respect to the reference line with the end point and this end point. So sine 45, both are sine 45. So this is equal to mu naught by 4 pi into I, the value of A. Value of A is equal to D divided by root 2 into sin phi 1. Phi 1 and phi 2 is equal to 45. Sin 45 plus sin 45 is equal to 2 into sin 45. What is the value of 45? Now 45, it means 1 is to 45 degree. This is 1 is to root 2. Sin 45 is equal to 1 by root 2. Cos 45 also is equal to 1 by root 2. So this we can write magnetic field is equal to mu naught by 4 pi into root 2 I divided by D into 2 into sin 45 is equal to 1 by root 2. So this and this get cancelled and this will become 2. So we can write, so the magnetic field due to 1, the segment AC, due to wire AC is B is equal to mu naught 1 by, this is pi d, so this will become 1 by 2 mu naught I divided by pi into d. 1 by 2 mu naught I pi d. So this is the magnetic field produced. And what is the direction of magnetic field? See, this is the conductor. Current is flowing this way. So we put the thumb and we put the curl. So curl means here it is going inside, it is coming outside. It means this side, what is the magnetic field? Here it is going inside. Here it is coming outward. Outward means at this point the magnetic field is outward. So second we will find for this another segment. Which segment? We will see for the segment BC. For BC, first see here the application of equation is very simple. See, this is the point P and this is the segment BC, which is at a distance of D. And this is the perpendicular distance, therefore this is here. Now we join this perpendicular line is the reference line. With respect to reference line, one end is joining one end, another end, we join one end and another end. This reference line and the line joining one end is making an angle, we call it as 0 degree, because this is the perpendicular distance line, that is A, and one end also making the same. It means phi 1 or phi 2, we can call it as 0 degree. And what is this? This is point P at which we are interested to find out magnetic field, and another end, that is B, this is C. When we join it, we measure the angle with the reference line up to this point. What is this? This will be 45 degree. I am talking about this one. So this is 45 degree. It means phi 2 is equal to 45 degree. So what about the magnetic field? The magnetic field is equal to mu naught by 4 pi into I divided by A. What is A? Here A is equal to D. A is equal to D, because this is the perpendicular distance with respect to this segment is this distance, which is equal to D. A is equal to D into one angle is sin phi 1. Phi 1 is equal to sin of 0 plus another angle sin of phi 2 is equal to 45. This is 45. Sin 45 is equal to 1 by root 2. So this is equal to mu naught by 4 pi into I into D. In place of A, it will come D. Sin 0 is equal to 0 into sin 45 is equal to 1 by root 2. So due to segment BC, magnetic field, we call it as B1. vector because the direction also included. B2, the vector. This is equal to mu naught I, we separate mu naught I pi d. Mu naught I pi d. Mu naught I pi d, if you separate it, what else left out? Mu naught I pi d is equal to 4 root 2. This is 1 by 4 into root 2 multiplied by 1 by 4 root 2 multiplied by this one. The second one we have calculated. Now we will find out the direction. See, make it as a direction. See this one, the current is, how the current is flowing this way. This way current is flowing. If this way current is flowing and we put the thumb in the direction of current and the curl will be here. It means this side of the conductor will be inward and this side will be inward. This side will be inward, this side will be outward. This side will be inward. See, like this. Then you hold it like this. This side it will go inside, this side it will come outside. And you put. So it means we are interested to find out what is at this point. Due to this conductor, it will be outward. Now, third one we are interested to find out due to the segment. Which segment? We have got the segment. We have found out for this one and we have found out for this one. So third, this one, and this is the line, that is AB, where this is the P point. So we will draw the perpendicular distance with respect to the wire. This is perpendicular, this will be A. And we join one side with the P with the one end and P with the another end. And we measure the angle. This is the reference line and this line making an angle of theta. So phi 1 is equal to 0 because the angle between the reference line and the line joining P with the one end is equal to 0. And this is, what is this value? This value is equal to 45. The line P joining with the other end, that is making an angle of 45 with the reference line. This is also, see here, this is reference line, this is the line joining both. So here phi 1 is equal to 0. Now here phi 2, what is phi 2? With respect to the line, it is making an angle of 45. Phi 2 is equal to 45 degree. Okay, now we have to find out the magnitude. So B, according to Biot Savart law, is equal to mu naught by 4 pi into I divided by what is A here? The perpendicular distance, which this segment, the perpendicular distance is this one. With respect to this conductor, the perpendicular, this is the perpendicular distance which is equal to D. So it means A is equal to D here. So we will write A is equal to D into sine of phi 1, sine of 0 plus sine of phi 2, 45. So it's equal to mu naught by 4 pi into I divided by D. Sine of 0 is equal to 0, sine 45 is equal to 1 by root 2. So this we call it as a B3 because this is B2. And third for the segment AB, for the segment AB, that we call it as B3 vector is equal to 1 by 4 root 2, 1 by 4 root 2 into mu naught I divided by pi d. We have to find out the direction. Since the current is flowing this way, we are interested to find out at this point. It means the magnetic field will go into this side. This side will be into, this side of the conductor will be into, this will be coming out. It means we are interested point P is this side of the conductor, so this will be like this. So see, you have to, for this conductor, with respect to the conductor, the point P is this side. So the magnetic field will be into. Here also, the magnetic field will be into this side of the conductor into the plane, out, this side is out. For this one, the current is coming here, it will be into, means here it will be coming out. So this is the magnetic field. So we got magnetic field due to all the segments. Now what is the magnetic field? Magnetic field, all the net magnetic field is the vector sum of all the magnetic field produced due to AC segment, BC segment, AB segment. See, this is other side. If you keep coming out as minus and this is as plus, this is as plus. If the answer is coming in minus, it means outward. If the answer is coming in plus, it means inward. So B net is equal to B1 plus B2 plus B3. So B1, what is B1? B1, this is B1 is equal to mu naught, we will take mu naught I pi d out, and this is, it is outward. Outward means we will take it as minus half, and second is B pi mu naught plus 1 by 4 root 2. See, if we have taken this magnetic field as plus and this magnetic field is minus, there is it may be, we can take it in a reverse way also. This may be minus, this may be plus. If the result is coming in plus, it means it is inward. If the resultant field is coming in minus, it will be outward. This way we have to take. And the next one also, 1 by 4 root 2 is equal to mu naught I divided by pi d. So 1 by 4 root 2, 1 by 4 root 2 is equal to 2 into 1 by 4 root 2. So this will become root 2 by 4 is equal to root 2 by 2 into 2 is equal to root 2 by, this is root 2 into root 2, 1 root 2 will get cancelled, root 2 into root 2 into 2, this get cancelled. So this will become into minus of 1 by 4 root 2, 2 into 1 by 4 root 2, 2 into 1 by 4 root 2 is equal to 1 by, now we will calculate 2 into, this is 2 into 1 by 4 root 2, 2 into 1 by 4 root 2 is equal to 2 into 1 by 4 into root 2 is equal to this becomes 2, 1 by 2 root 2, 2 into 1 by 4 root 2, 1 by 4 root 2, okay, it's equal to plus 1 by 2 root 2, this is the, this will be negative or positive, this is minus of, it is 2 plus something, this is denominator is bigger, it means 1 by big denominator will be smaller, so 1 by 2 root 2, so this value will be bigger because minus of, this is minus half is equal to minus 0.5 and 1 by 2 root is equal to 1 by 2 into 1.4, root is 1.4, this is equal to 1 by 8 approximately 2.8. So since 1 by 2 is bigger, this bigger, so this will, it's when we make it, it will be smaller. It means this value will be smaller. That's why this is smaller, this is bigger. So the answer will come in negative. Negative means it is outward. So net magnetic field is equal to mu naught I divided by pi d into, we can take 1 by 2 into 1 by 2 outside, 1 by 2 outside, it, that is 1 by root 2 minus 1, 1 by root 2 minus 1, this is 1 by root 2, 1 by 1.4 minus 1, minus 1 by 1, when it goes, so this will be smaller value, this will be smaller value, this will be bigger value. When this is the bigger value in this case, 1 by half we have taken, this will be bigger value, it means the answer will come negative. The answer will come in Negative means we have taken, negative means the outward magnetic field, the net magnetic field will be outward. So this is the resultant magnitude of the, this is the magnitude of the magnetic field, and this is the direction of the resultant magnetic field due to this segment, line segments at P.